welcome to the next video in the systems programming video series. In this, we are finishing up the jam number 4, so we're answering question 3. And so in this question, we are going to use GDB and objdump to reverse engineer the binary executable secret. And so it looks like we can run the program. Yeah, let's go ahead and run the program. So if we run the program, guess the mystery number 1. I am wrong. And so it exits. Here it says, yeah, and you can see it's basically the same thing. So the mystery number is not 1 or 39, but lots of other numbers left to guess. So that's the program that we're going to be trying to reverse engineer. What functions does main call list in execution order? So it's going to help if we perform an objdump. So let's down here say objdump. And we're going to pipe that into output.txt. And oh, I think I need to put the secret here. There we go. Looks good. If I pull this up, you can see this here. We could use VS Code and its, sort of text editor to explore that. We might want to just practice using less, so let's try less, and we're going to look in the output.txt file. And let's go ahead and type this /main to skip down to the main function. Well, it's searching for the main function, so let's just go. Oh, right. So I think what I actually want is main. And then, oh, did I mess something up? I don't know. Let's try quit. Do that again, say /main, and then use next, or just pressing the letter N, scans down to this assembly for the main function. And if we want to know what functions it calls, then we should be able to find that here. So here is a call to a function called mystery. There's a call to a function called foo. There's this call to print. There's this call to scanf, a call to put, another call to put, or put-s. And that seems to be it. So if we, then I guess there's this, which is stack check fail. We maybe want to include that in our list of functions. Not sure exactly what that is. We could look it up, but I'm not sure it's worth looking up right now. So that seems to enumerate all of the function calls. So we could write those out. That would be the answer to this first question. So that's the functions that it calls in execution order. What are the values of ESI and EDI before the first function call in main? So let's go to the first function call in main, which we said was here, this mystery. And we would like to use GDB to sort of debug this thing and get to this moment in the code. So let's see how to do that. So let's quit less, and let's now call GDB on the executable file, so secret. Now I want to set a break at main so that we stop just at main. And let's go ahead and run that. So we hit the breakpoint at main. It would be nice to disassemble main and be able to see what all is going on here. So let's say disas, so that's disassemble m. And this is doing what? So we've got the end br64, whatever that is. We do the usual initial stuff whenever we are starting up a function. And we're probably making some space for some initialized values. We don't get to look at the source code, so we have to guess somewhat at what is going on here, but this is probably making space for some variables that were declared. It looks like we move some kind of a value into RAX and do some various moving some memory around to some places. There's an XOR thing. Not sure why we would XOR that, but in any case, let's not get too bogged down into these nuances. The important thing is that right now, because of where you see the arrow right here, we can see that we are just before the call to do this subtraction on the stack pointer. So that has not yet executed. Where we'd like to get down to here, and then when we're down here, we'd like to print the content of the EDI register. So let's see, can we actually place a break right at this assembly instruction? So that's done. Now I'd like to break, and I believe if I recall correctly, you have to, when you're putting an assembly instruction address, you have to lead with a star. That doesn't look like it copied correctly. Let's compare that. So does it end in 201 for my machine? And by the way, your machine will probably have different addresses, but ends in 201, so maybe that is now good. And so let's see what happens. It set the breakpoint. If I run, oh, sorry, I don't want to run. I want to continue up to the breakpoint, which it just did. It's telling me that I'm at this instruction in main. Let's just go ahead and disass. And now we see that, in fact, exactly what I wanted to happen did happen. I am right here before the call to the mystery function. And so what do I do next? I want to print the content of the register EDI. And in GDB, you can say print, but to get the register, you actually say $EDI. 62. Now, EDI is the parameter of a function call, so presumably what we're seeing here is that I would guess the mystery number is supposed to be 62. You would pass that in. It's going to check if the number that you input is the number that it's looking for, and mystery would return true if it is. So that is probably a good guess about what the mystery number is. In any case, that definitely answers, oh, and that's the EDI. We would also like to know what ESI is. And here that's 87. Oh, well, which one is it then? So I forget off the top of my head which register means what. So first six parameters. So DI, so the full register is RDI, but we can talk about EDI. And then there's RSI. So I think this is supposed to be the first parameter of the function. This is supposed to be the second parameter of the function. And so we're saying that the first number is 62, the second number is 87. And do we want to think hard about what's going on here? So we move EDX, which is presumably something totally different. RD, that's supposed to be, I guess, the third argument. The first six parameters of the registers, in registers that. So I'm not sure why we're even bothering to use the EDX register, but it gets put into ESI. EAX is put into EDI. So the return of something, like, because EAX is supposed to be like a return register, and it's getting its value moved into EDI, which we said was the first argument. So I think it's probably the first argument, right? RDI, that's the first argument. That's probably the only thing, one might guess, that's the only thing going into mystery anyway. So RDI, or the abbreviated EDI, is still my guess for what the mystery number is. Let's test out the guess. Let's quit. So yes, quit. Let's run the program. So .secret. Guess the mystery number, 62. Ooh, what if we did 87? Wrong. Well, I guess maybe we're supposed to investigate this further rather than already making this guess. So, but at least we know what EDI, right? So we've answered that part of the assignment, which is just to say the values of ESI and EDI before the first function call. What is the return value from the first function call? So maybe that's the mystery number. So let's get back into GDB. Let's set a break at main. Let's set a break at the address. Is that still, if I paste that, there it is. Great. Let's continue. Oh, seems to work. And so now I actually want to go beyond the function call, which I think I just say next. Let's see what happens. Single stepping until exit from function main, which has no line. We guess the mystery number. So I guess I'm just going to say 62. So I guess at this point, so I think what happened when I pressed N was that it just went too far. Oh, let's go to, no, it doesn't do const. So why did pressing N take me all the way to something I didn't want to go to? I would have hoped that it would just take me, oh, well, that's right. But is it, I guess it's step. Right. N is for lines of C code, which maybe is why it took me much farther than I intended to go. Whereas I guess step is for assembly code, so maybe SI. But now I am probably inside of the mystery function at this point. Maybe I should have set a breakpoint to just after, since I know I can do that. So probably that's what I should have done. But now that we're here, let's just see what is around. I am now inside the mystery function. So you can see that after calling disass, and it says dump of assembler for the function mystery. So I am inside the mystery function at the very beginning of the mystery function. Let's just continue stepping and see what happens. So if I now look for where I am in this, that looks fine. And let's just keep stepping. And now I'm back to main. Let's see where I am in main. And I'm just after the function call, and so it is moving the return value, but most importantly, what's going on right now should contain in EAX the return value of the function. So let's go ahead and continue, and I would like to print the content of EAX 74. I wonder if that is the value, the mystery number. So in any case, I have now answered the question, what is the return value from the first function? It seems to be 74. I am curious to see whether or not that is the mystery number. So if I enter 74, interesting, not the mystery number. Oh, well, so I would hope that it was that simple, but I guess maybe we just need to continue really understanding what the rest of the assembly is. I'm trying to go fast. I want to like see the answer, so I'm like making these guesses before I really have even a good reason for thinking that these things are the mystery number. So let's see what's going on here. There's a bunch of move calls, right? A bunch of data gets moved from here and here to there. We call on foo. We move. We load effective address. Move. Call print. Load effective address, move data around. Scanf. So this is where the user input starts, right? So it's when you reach this line or compute this line or whatever, execute this line. That is when it asks you for your input. And so this should cause, I guess, this address in memory to get moved over to the return address. And then we compare that return value to something. And this is something in memory at this point. But I think the important fact is that this is a comparison, and that's what you would do to check the value of a given number. And this down here, JNE, I think that's jump not equal. And so that's what you do to like go to some instructions when the value stored somewhere is not equal to something else, or often just not equal to 0 or something like that. But in any case, or it just contains a signal for whether an earlier comparison like this one came out true or false, basically. But in any case, the point is that I think by all of those considerations, if we navigated to this instruction, to this point in assembly, and investigated what the value in EAX is here, I think that actually is probably, or no, actually, I guess that is the return. That's what you enter when you respond to scanf, but whatever is here, that should be the mystery number. It should be at this point located in memory there. I wonder how it got there, this minus XC, basically minus C from the base pointer. Does anything earlier put data in minus C from the base pointer here? Yeah, and that's the return value of foo. So I wonder if maybe basically the return value of foo actually holds the mystery number, and then on this line, that value gets put into memory somewhere, and then later on you call on it to check whether it's equal. But so that's my new hypothesis. So let me go ahead and test my new hypothesis. But what am I even supposed to be doing? So I think I've answered for what is the value of EDI before the second function call in main. So maybe okay, before I get ahead of myself, let me just go ahead and answer this question, even though I'm not sure that's where the mystery number is. But let's go ahead and answer that. So let's go to the second function call. And the second function call is this one. And so it happens at this address. So I want to set a break here. So can I break star, put my address there? It seems to accept that. Run. Here we go. Let me just see where I am. I always like to just know for sure that I am where I think I am. So yes, I am. And it wanted to know the value in EDI. So let's go ahead and print EDI, 74, which is the same value as we saw in a previous part of this. So not sure how interesting that really is. But so I guess we now know that. But now we are supposed to find the secret number. And as I was conjecturing a moment ago, I think that if I come to here and inspect the value of EDX, or sorry, EAX, then that should, I hope, tell me the mystery number. So let's see what happens. Let's break at this thing, continue to that point, print $EAX, 174, interesting. So that's my new guess about what the mystery number is. Let's go ahead and quit. Let's test 174. There it is. Cool. So that's really satisfying. That's really nice. And I don't know, is there anything more that is interesting to try out? I got the secret number. Oh, that's it. End of video.